Hi guys, okay, let's get started with the setup of the pipeline. Okay, so before we start, I'm just going to do a quick intro to the RStudio IDE. So on the bottom left here is the console space where you're actually going to send your commands or your function calls. But up here on the top left is the script space. So I actually do everything in the scripting space. So basically think of this as a scratch pad for all of your thoughts and commands, and you can send your calls, your function calls directly from your script space to the console using some shortcut keys. So I do everything here just to make sure I document everything I do. On your top right is your global environment. This is where all the output to the functions will, for the most part, be saved within R. And on the bottom here is your viewer. So we use this viewer for a variety of things, to see where your current working directory is, or to look at plots. And I primarily use it to look at help pages. So yeah, let's get started first by loading the R packet, the smart package. So you do that by using the library function, right? And you would type the name of the package you're loading. So we're loading smart, and you would press Control Enter while your cursor is currently on the line of code that you want to run to send it straight to the console. So I'm just going to press Control Enter, and you can see that one of the first things that happened was the quartz function was loaded. This kind of is an indicator that the smart package loaded correctly. Okay, the second thing you want to do first is look at the help page for smart. So we're going to do that with the with the help operator. That's just a question mark followed by the name of the package. And let's press Control Enter and run this. So you can see that the help page popped up automatically. It was actually on this before, but it popped up again at the top. And so you can scroll down here, down this page, to look at all the functions in the actual package. And these first three functions, setup PL, impsort, and get saved paths, we're going to walk through those in this video. So I'm just going to press on setup PL to show you the help page for this. So first in the help page, there will be a description about what the function does, and then a usage line. So this usage will show you first how to call the function. Just type the function name, setup_PL, and then you use parentheses, and then you would type any variables that you need. If a variable is set to null, it means that it's basically an optional variable. So we can call this function without entering in the variable called setup. So I'll first demonstrate that right now by calling the setup PL function. Oh, sorry, before I forget. The output of a function sometimes, well, for the most part, should be stored if there is an output. And so you can see the output, whether the function has an output, by going to the value portion of the help page. You can see that I've italicized the recommended variable name. You can, of course, call it whatever you want, but I prefer to use the italicized recommended name because it's trust me, it's simpler that way. So we're going to store the output of this function in the setup variable, and we're going to call the setup function just by typing setup. And again, because the variable or the argument is not necessary, it's set to null, we can just run it like this. And you can see that an interactive window pops up that asks you first whether you want to register a partial or a whole ramp. Now, before we get started on entering in, setup parameters for this pipeline, I forgot to mention that you should have first downloaded the example dataset from the tutorial website. So if you haven't done that, I do that now. So just go to the tutorial website and go to example data, and then hit this link to download the raw dataset. The instructions are right here. So I've actually already done that to save time. I have that in my Seagate external drive right here. So also, this pipeline or the example dataset requires a lot of space, so that's why I've saved it to this drive right here. My drive has about 1.5 terabytes of space. That's because the raw data, and this is the raw data right here, is about 50 gigabytes. So each channel of data is about 24, 25 gigabytes. And you also want to make sure you have enough space for the output directory. So the output of this pipeline, based on this data set, is about 12, 13 gigabytes. So you want to make sure that you don't run out of space. So let me just click on these folders and show you what the raw data looks like. The raw data is just a bunch of TIFF images with one image for each Z slice. And channel 1 stands for the segmentation channel. That's the FOSS channel that we're using. And channel 2 is the autofluorescence channel. This is the channel we'll use for registering the atlas to the brain, or the contours of the brain. Now that we've downloaded the data, let's get back to the interactive console. Okay. Do you want to register a partial or whole brain? Because the dataset we downloaded is a intact volumetric mouse brain dataset. We're going to say we're going to register a whole brain. So we're going to type in W, and then we're going to enter our animal ID. So it doesn't really matter, but this particular animal was named 1602. So we're going to type in 1602. We're going to enter your initials, and then you're going to enter the path to the registration channel folder. So we were just there. Again, channel 2 is the registration folder, so we'll copy and paste that. And then we're going to enter the path to the segmentation folder. That's channel 1. That's the channel that FOSS is stained in, or was imaged in. And then you want to enter the path to an output folder. So if it doesn't exist, create it. So you can save this in any directory you choose. I'm going to save it to the same external drive that I have my raw data in. So I would create one now. That's, just example output folder for the purposes of this demonstration. And I'd create it, and then I'd copy and paste the path to the output folder. Okay, the next series of questions asks a bunch of sort of imaging parameters. So the first one is, what is the spacing between adjacent Z images? In this dataset, the spacing between adjacent Z images was 2.5 microns. Because it's asking for this in millimeters, that'll be 0.0025 millimeters. And then it's going to ask you for your most anterior coordinate. So SMART aligns your data set along the anterior posterior axis by aligning a bunch of your raw images, a subset of your raw images, to the actual atlas. So we call these reference plates. So in this schematic right here, the first thing that we want to do in the setup PL function is align the very first and the very last plate manually to the atlas. And to do so, we're going to want to open up some of our raw images, basically the first usable raw image and the last usable raw image, and we're going to try and hunt for them in image rendering program. I like to use ImageJ, and we're going to manually align them using this user reference atlas. Okay, so this, you can find this in the tutorial website. That's, again, in example data. You can download this standardized atlas. These are just the SVG vectorized plates from the whole brain package. But here we provide both the plate number and the AP coordinate. You'll see that it doesn't start at plate 1, and it doesn't go all the way to the very last plate, actually, in the Allen Mouse Brain Atlas. That's because a few of these plates, we've noticed this caveat, can't be registered because there was just some errors in registering them in the base package. And so we've provided in this reference atlas basically all the plates that we've had experience using and should work. So we'll use this as a reference to align this example data. We also have a custom atlas that we made. It's a little less official. It's just a PowerPoint file, but it's basically those same plates, and here we list the plate number and the AP coordinate. But we've also aligned one of our example data sets sort of in a manually intensive way. We've aligned them to what our autofluorescence image is. And so you can see that we sort of qualitatively did this, and so this is just another qualitative reference for users. But this is probably the better standard, just looking at the PDF, because again, using the PowerPoint, you'd be, you don't want to fall into the error of aligning to our experimental data set rather than the actual atlas itself. Okay, so first we're going to align the first image. So we'll go back into our raw data files, and we're going to look for the first usable image in our registration channel. So if you throw in this first image here, based on the way this data set was scanned, there's actually a bit of empty space in the front of the brain. And so we want to find our first usable image. So I know from our demonstration in the online tutorial that the first usable image that we used was 200, a Z of 200. So we'll throw that into image J, right? And you'll see this is what pops up, right? So we want to align this to the reference atlas. Okay, so all we have to do is scroll down through the atlas. Oops. How do I get this to expand? Okay, we'll just scroll down the atlas and basically say, qualitatively, which one does this look like the most? Okay, and I know that we used, I believe, plate 2.82. And so we've aligned now our Z image of Z200 to our anterior posterior coordinate of 2.82. So let's enter that into the interactive console. Our most anterior coordinate is 2.82. And the Z image associated with that is Z200. Okay. And our most posterior coordinate. So it's possible that the raw images go a little beyond the very last plate that you can actually register. So the very last plate you can register is negative 4.77. If your data set goes beyond this, then I would suggest setting, basically aligning to the anterior posterior coordinate of 4.77. And unfortunately, you won't be able to segment and register any of your data beyond this. But let's look for, because I know this data set goes beyond this coordinate, let's look for the plate we chose to align with, negative 4.77. I believe it was, I'm going to cheat a little bit, go to our tutorial, so I've done this already, and we said it was 2,925. So I'm just going to open that real quick to show you guys. 2,925. Yeah, that's right here. Let's open this up. Okay. So this is the plate that we lined up with the atlas plate. So let's enter that into the R console. Your most posterior AP coordinate is negative 4.77. And the Z image is 29.25. Right? Now I'm second guessing myself. Yeah, 29.25. Okay. Okay, and then the interactive console will show you all the parameters that you just set up, your Z spacing, your first and last AP, and then it will also show you a bunch of these internal reference AP coordinates. So these are automatically set. You can see that you didn't initially get the option to set your own internal reference coordinates. The reason I did that was, it's easier to just take the standard, but if you do want your own, you can easily change that. A couple other things that you didn't initially get the option to choose was your registration step and your segmentation step. And I'll explain what those are in a little bit. But first, let's say we wanted to change one of these internal reference coordinates. you can just say, yes, do you want to change any settings? And it would take you to this menu where you can enter a bunch of settings that you want to change, like the internal AP coordinates or your your registration and segmentation step size. So let me first explain what they are by manually correcting them. Okay. So what's your spacing between registrations? This means that in the actual registration loop, you can register an Atlas plate every 100 microns. So every 100 microns is 0.1 millimeters, right? But if you want to actually register every 200, you can. It'll just be a little bit of a lower resolution registering across the AP axis. And I wouldn't recommend it. I would recommend taking the default of 100 microns. Just because your data set will be less accurately registered. Okay, and segmentation step size is basically, do you want to segment every single one of your images? Or do you want to segment every 2 images or every 3 images? So you have that option here if you have an incredibly super high-res data set, but I normally just take the default of 1. Okay, and you can set your internal reference coordinates. You can take the default, or you can modify them. So if you want to say, oh, I actually don't want all of these, you know, I just want, I want to start at, 1.1, I don't need to use any other plates anterior to this as another reference. I can do that, and I can just enter that. And the loop will display all of your new parameters again, right? And you can see that I changed this. So I'm going to go back and actually take the default of the internal reference AP coordinates again. So enter this, just copy and paste it. But the point of being able to modify this is you might have some reference plates. You might have some reference plates in the middle of your data set that you are particularly tuned to, that you know the landmarks for. You might have some anatomical landmarks that you're very familiar with. So we wanted to give users the options to set their own anatomical landmarks. So once you're satisfied, you would just hit no. You don't want to change any settings. And you can see that we've created another setup variable right here. And if we were to click on this, you can see all of the information is stored in this setup variable. And there's a couple more basically sort of hidden variables right here that will get filled out later by the other functions. Okay, so we're done setting up the pipeline using the setup pipeline function. Okay, the next function we want to use is imsort. This is basically a path sorting function to store all of the paths for your raw data into the setup variable. So some of these parameters in the setup list are unfilled right now, like image paths and save paths. So we're going to quickly create that using the imsort function. So let's first click on the help page. And you can see that there's only one required variable, and that's the setup variable. So you can see, for the most part in this pipeline, setup is going to be the most important argument that all of the functions use. So there are a couple other optional arguments, but we're just going to take the default for them. Well, actually, let me explain. Extension is an argument that asks what format your raw image files are in. So because ours are in TIFFs, the default is TIFF, but if you saved your data as JPEG or PNG, you can definitely change this to JPEG or PNG. And I'll explain what separator and position are in a little bit, because it's kind of explained through the running of this function. So let's call img sort, and we can see that the output of this function is the setup variable again. So let's just set the output to this as the setup variable. And it takes the setup variable as an argument. So let's run this really quick. Okay, you can see that when we run this, a sort of like tutorial on how this function pops up. So let's just read it really quick. So during image sorting, your image naming convention will be found and split based on the separator you entered. The default is the underscore. So this example image path will be split to partial image names based on the separator. This tutorial will also give you your first image, right, from your actual data, and it will split it based on what you entered as your separator. Again, the default is the underscore. So your first image was split to, all of these different names, but it's asking you for your name position of your Z number. Okay, so the name position of the Z number in this naming convention is going to be name position 9. So we want to enter 9 as the name position. Okay, so we can check that our setup variable has actually stored the image paths and sorted them by using the $sign. The $sign just basically accesses different parts of a list variable. If you create a list variable and you name the different parts of your list, which I did, you can actually take a look at what's stored in that part of the list. So here we've stored the image paths, and you can see that everything is sorted really nicely. Okay, and I recommend using this image sorting function. I know there are other path sorting functions in R, but this one is pretty much foolproof for any issues with Z number naming. For example, sometimes there's a 0 in front of a number like 001 or 002, and sometimes some of the other path sorting functions sort a little weirdly, so that's why this function is in here, and it automatically sorts these paths into the setup variable for you. Okay, so we're done with that. The next thing that we want to do, let's go back to the help page, is get the save paths and automatically generate the save directories based on the output directory we set in the setup variable. So let's just read through the descriptions. Usage is get save paths. The only required argument is setup. And again, the return variable I've set as setup. So let's run this. Setup. What are we running? Okay, get save paths. So this does a couple things. First, it automatically generates a bunch of save paths for you in the output directory, and it saves these save paths in the setup variable as well. So let's go to the output directory that we created, and you can see that a bunch of subdirectories have been created automatically by this function. Okay, another thing that you want to pay attention to is the environmental save path is created. Okay, so this is updated based on the information that you entered in your setup variable in the setup PL function. Remember, I entered in my initials. So if somebody else wants to work on this data set, or you just want to save the environmental, the global environment, what I would do is make sure that your initials are correct on the setup PL function. Okay, so you can actually modify your setup list in your setup PL function by typing in setup as the optional variable, right? So let me show you right here, setup underscore PL, setup, right? Actually, I'm going to put that up in the script. you can actually look at your current parameters in the setup list by just setting your setup variable as your argument in the setup PL function, and you can go ahead and change, who's working on it on this data set. You can change your user initials, on this particular day, and you can say, oh, my initials are now, KJ, if I was a different person. And then you would hit, okay, I don't want to change any more settings. And you can see that this is now updated. So if you want to save the global environment, all you have to do is save dot image, right? Save dot image, and then type in setup, and then use the money sign, and then scroll down to save paths. Okay, and then use one more money sign, and go to environmental save path. Okay, and when you type that, and you press enter, all of your information for the day will be saved. And so we can check that by going to the R data folder. And you can see the data I've had from this session is now saved. And so what I'd recommend is, for every new day that you're working on this pipeline or a particular data set, I would make sure that the user's initials are correct, and then I would run the getSavePath function, right? The getSavePath function just once again at the beginning of every day. So you would just say, you would just run this function again and save it back into the setup variable. Yeah, I can just copy and paste it up here. And this will update the user initials and the date for you, and then I would run this save global environment function, and this will make sure that you keep track of all of your progress every day, and that you document who's doing what, so that if there are any mistakes, at most you lose is a 1 day's worth of work. Okay, so that was it. We're done with the pipeline setup. So in the next video, we'll be talking about the actual alignment of these reference templates to the atlas.